Hello everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer quiz 4 questions. Altogether, we have 4 different questions and let's start with the first one. Question number 1. 3 moles of hydrogen and 3 moles of iodine are introduced into a 2-liter container at a temperature of 490 degrees Celsius. Determine the concentration of hydrogen iodide when the equilibrium is established, given that the reaction quotient for this reaction is 45.9. In order for you to answer this question, you need to be able to relate between the reaction quotient given to you in the question with the equilibrium constant. At equilibrium, your reaction quotient, which is your QC, should be equivalent to your equilibrium constant KEQ. So given to you in the question, your QC is 45.9. Therefore, your KEQ is equivalent to 45.9. But in the question, you were asked to calculate the concentration of HI, hydrogen iodide. So, in order for you to use this information, you need to write your ICE diagram. Alright, before we can proceed with writing the ICE diagram, we need to be able to write a balance equation beforehand. So this equation or this reaction consists of hydrogen reacting with iodine. So it will produce the hydrogen iodide. So what are we going to do now is we need to balance up this equation. Since in the reactant you have 2 hydrogen and 2 iodine, so there must be 2 HI being produced. Alright, now we are going to continue on with writing the ICE diagram. So in the question it states here 3 moles of hydrogen, but be careful when you want to write your ICE diagram, it must be in concentration and not in moles. And then in the question also it gives you information whereby it is being put in a 2-liter container. Therefore, we can calculate the molarity or the concentration of the hydrogen. So, molarity is equivalent to mole. So, you have 3 moles over liter. So, have 2 liter. Same goes with iodine. You have 3 moles of iodine and the volume is 2. And then at the beginning of the reaction, there's no hydrogen iodide is being formed. So here, initially, there's nothing. So 0. Right? So by looking at the balance equation, we are going to look at the C, which is the change. So since here, we only have 1 hydrogen, so negative X. Why is it negative? Because it is the reactant. So whatever in the reactant must be negative because the amount of reactant shall decrease to produce the product. So same goes with iodine is going to be negative X. Right? So when you look at your hydrogen iodide, you have 2 over here. So since it is the product, so you have to be positive and you have 2 over there, so 2X. So at equilibrium, supposedly it's going to be 3 over 2 minus X. This one is 3 over 2 minus X as well. And also this one positive 2X. So from here, you can actually calculate your KEQ. Or you may write KC as well because given to you is the concentration. So the KEQ is equivalent to whatever in the product, which is the HI square divided by whatever in the reactant. So you have H2 and also iodine. So what we are going to do now is we are just going to plug in all this value and make sure that you know that the value of KEQ is the same as your QC, the reaction quotient given to you in the question, which is 45.9. Alright, so since we already know that your KEQ is equivalent to 45.9, so we're just going to write here 45.9 is equivalent to whatever in the product. So your product will be 2x square. So you're just going to look at the equilibrium divided by your hydrogen is 3 over 2 minus x. So since the iodine is the same value, so we're just going to put square over here. So since the up and down are squares, so the easiest way for us to remove that is just making a square root of your 45.9. So therefore it will be equivalent to 2x divided by 3 over 2 minus x. So what you're going to do now is find the value of x. It's a simple quadratic, so this one shall be equivalent to 6.7750 equivalent to 2x divided by 3 over 2 minus x. Right, let's continue on. So from here you need to rearrange this and you shall get 2x is equivalent to 1.5 minus x times 6.7750. So therefore you will get your x is equivalent to 10.1625 divided by 8.7750. Therefore x is equivalent to 1.1581. Right, so from the previous calculation we get your x is equivalent to 1.1581, and in the question you were asked to determine the concentration of Hi. So your Hi is over here at equilibrium, so the concentration of Hi is actually equivalent to 2x. So since the value of x is 1.1581, therefore the concentration of Hi is equivalent to 2 times 1.1581. Therefore you should get 2.3163 molar. So this is the final answer for the first question. Let's move on to question number 2. The equilibrium constant of a reaction between hydrogen gas and iodine gas is 6.2 times 10 to the power of 2 at 25 degrees Celsius. What is the Kp for this reaction at identical temperature? In the question, it states that the equilibrium constant is equivalent to 6.2 times 10 to the power of 2. So since it doesn't mention whether it's a Kc or Kp, so we will assume that this is a Kc because you were asked to calculate the value of Kp. So in order for you to calculate the value of Kp, the first thing that you need to do is you need to be able to write a balanced equation for this reaction. So in this reaction, you have hydrogen gas, so make sure you write the state of matter, plus iodine, also gas, will produce 2 hydrogen iodide, which is in gaseous form as well. So from the question, you know your value of Kc, which is equivalent to 6.2 times 10 to the power of 2. Therefore, in order for you to calculate your Kp, you need to use the formula of Kp equivalent to Kc or T to the power of delta N. So now the next thing that we need to do is to find what is delta N. So delta N is product minus reactant. So how much product you have here, which is 2. So how much reactant? So 1 plus 1. So 1 plus 1. So it means that 2 minus 2 equivalent to 0. So your N is actually equivalent to 0. So the Kp is equivalent to your Kc. So you just plug in the value 6.2 times 10 to the power of 2 times your RT. So R is the gas constant, 0.0821, and your temperature is 25 degrees Celsius. Please make sure that you convert that to Kelvin. So 25 degrees Celsius plus 273, so you should get equivalent to 298. So times 298 to the power of 0, because your delta N is equivalent to 0. So your Kp is actually equivalent to 6.2 times 10 to the power of 2 times 2.4466 times 10 to the power of 1 to the power of 0. Hence, your Kp is equivalent to 6.2 times 10 to the power of 2. Right, so this is the final answer for the second question. Alright, just a quick side note. So maybe some of you might ask, so since you know that your delta n is equivalent to 0, so you know that whatever value here to the power of 0 shall be equivalent to 1. So should you do this? The answer is yes, because there will be marks for the conversion of the temperature and also marks for the value of R. So make sure that you to calculate all these things, and although you know the answer shall be 1, so it's just this value that is important, but still you need to show this calculation as well. We are now at question number 3. So the pH of 1 molar of HClO is 4.23. So calculate the Ka of this substance. Right, the keyword for this question is calculating your Ka. So in order for you to calculate your Ka, the first thing that you need to do is, as always, you need to write a balance equation of this reaction. So we are assuming that this is just a dissociation of HClO. So what we are going to write here is just HClO shall dissociate to H plus CiO minus. Alright, so after you have done writing a balance equation of this, so the next thing that we need to do is we need to write the ice diagram. Let's write the ice diagram. So given to you is already the concentration of HClO. So the initial concentration shall be 1. So at first there's no dissociation, so 0 and 0. So since it's all 1, so this one will be negative x, this one will be positive x and positive x. So it's going to be at equilibrium 1 minus x, x and x, right? So given to you is the pH. So the pH at equilibrium is such. So pH is equivalent to negative log concentration of H plus, right? So if pH is given to you, so 4.23 is the pH, so equivalent to negative log H plus. So you should be able to calculate what is your H plus. So it should be equivalent to 10 to the power of negative 4.23. So you should get the concentration of H plus equivalent to 5.8884 times 10 to the power of negative 5. So this is your H plus, whereby your H plus is actually equivalent to your value of X. In this question, you were asked to calculate the value of Ka. So in order for you to calculate the Ka is whatever in the product divided by whatever in the reactant. Therefore, what we are going to do now is write the Ka equivalent to concentration of H plus times the concentration of CiO minus divided by concentration of HClO. So we are going to plug in all the values, whereby the value of X is equivalent to 5.8884 times 10 to the power of negative 5. So I'm just going to write as X, and then only we are going to substitute that value, right? So you will get your Ka is actually equivalent to 5.8884 times 10 to the power of negative 5, this one square, divided by 1 minus 5.8884 times 10 to the power of negative 5. Right, so therefore you will get your value of Ka is equivalent to 3.4693 times 10 to the power of negative 8. So this is the final answer for the third question. Alright, now we have reached the final question for this quiz, question number 4. Refer to the chemical reaction below. So you have 2 sulfur trioxide will produce 2 sulfur dioxide and oxygen gas. The aforementioned reaction is at equilibrium. What shall a sudden increase in concentration of oxygen gas result in? Alright, in order to answer this question, you need to be able to recall the Le Chatelier principle. So in Le Chatelier principle, it states that the position of equilibrium will move in such a way as to counteract the change. So in this reaction, what we increase is the concentration of oxygen gas. So in order for it to counteract, so it means that it shall move to the left, making more reactant. So when you want to make more reactant, what we can say is that it need to decrease the concentration of sulfur dioxide, but we need to increase the concentration of sulfur trioxide. So this is the final answer for question number 4. Alright, we have reached the end of this video. So thank you very much for watching. I'll see you again next week. So take care, be good and stay safe. Goodbye.